G'day and welcome back to Build Some, and as you can see today we're out on the site, and what I want to show you in this video is the process of constructing what we call the subfloor frame, the floor frame itself, and then putting down the flooring. And this one's going to be what we call a platform floor system. So as you can see here, we've dug or excavated a strip footing around the perimeter of the building, and in the inside of the building we've got holes for blob footings, and we'll pour concrete in there shortly. The next step would then be to place into the strip footing our reinforcement, top and bottom of the footing, just to strengthen that up. The blob footings don't require any reinforcement, they just sit there as a bulk concrete. So we've done all the excavation, so we can pour the footing. There it is there, and you can see that it finishes below the ground level, generally about a course or 86 mil or so. And what that does is when we put the brickwork up, we can then backfill over the top of the footing just so it's not seen. Okay, so that's our strip footing around the outside and our blob footings inside. And once the concrete's set for long enough, generally a week minimum, then we can put up our dwarf wall. So our dwarf wall runs around the perimeter, and there's a funny coloured looking brick there. Hang on, let me fix that. What do I want? Change him, that looks better. So the dwarf wall runs around the perimeter of the building site, and it has vents built in for ventilation. And it's just a single skin of brickwork runs around the outside. It also has a hole there for our subfloor access door at a later date. Now, to reinforce the dwarf wall and to also give us somewhere to sit our bearers, we have engaged piers. So these are connected to the dwarf wall with ties. It's wire ties, or Morse ties they call them, so that it can't separate, and as the name suggests, they're engaged to the dwarf wall. Okay, they're just a stack of bricks on top of each other. They're spaced so that they line up with where the bearers are going to sit, and generally evenly spaced the whole way around. There is an extra one here, which is just there because that wall's sitting there by itself, because it's ends, so that's just there to reinforce that. So that's our dwarf wall with our engaged piers. We also have to have our isolated piers. So these ones sitting out here by themselves, isolated or sleeper piers. Okay, and they're going to pick up the bearer when it runs through. So they're spaced the same distance as the engaged piers, all determined by how far our bearer is going to span. Okay, so engaged piers attached to the dwarf wall, isolated piers out here in the middle. So that's our subfloor frame, if you like. Or subfloor. So what we need to do now, a couple of things we have to put on top of our brickwork. Firstly is the DPC, or the damp proof course. So nowadays they generally use a plastic or polyethylene type membrane, commonly called snakeskin, because it's got a scaly looking effect on it. And what that does is stops the moisture coming up through our brickwork and getting into our timber, which then stops the timber from rotting. Also, the ventilation will help if any moisture does come up, or if the ground's wet here, ventilation will help that dry out, and that'll stop our timber from rotting as well. The other thing that we have to take into consideration with our timber is we need to have at least 400 mil from our ground line to the underside of our bearer. That's got a couple of reasons. One, so we don't get moisture transfer, and two, it also lets us get in underneath and crawl around and have a look for termites and stuff later on. I'll show you that shortly. So the first thing we've put down is our damp proof course all the way around. Make sure they overlap wherever you join them or at the corners, so there's no way that any moisture is going to come up through the brickwork into the timber. On top of the damp proof course we have our ant capping. So it's simply a pressed metal, generally galvanized cap, which has a turn down at the side, so it overhangs the pier or the little dwarf wall, has a turn down on the sides, and what that does is the termites, it just stops them from coming up. They can work their way up through the voids in the mortar and the bricks, and they could, if the cap wasn't here, just go straight through our pier into our timber, and you'd never know they were there. By putting the cap there, they can't eat their way through the cap, so what they have to do is they come out to the outside of the cap underneath it. They then start to build mud tunnels, or they build them up from the ground, and they actually have to build mud tunnels out all the way around the cap and then into our timber. I've seen pictures of that, I've seen it happen. It does happen, but what it does is, because they've had to come outside of the pier, we can actually see them, and with regular inspection then we can stop them. So none of our termite systems that we have will 100% stop termites. They only bring them out into an area where we can pick them up with regular inspections. So you've got to have your ant cap. So there's full caps for our isolated piers, there's half caps for our engaged piers, and there's continuous lengths that go around for our dwarf wall, and they're all joined where they need to be joined with, well, back in the bad old days, they used to solder them. Nowadays they're caulking agents, or like adhesives that are termite certified, so you can use those and some pop rivets to join the ant cap together. So now that we've got all that done, we are ready for our timber, or our timber members. And the first one is going to be our bearer. So the bearers generally run the length of the longest dimension of the building. So in this case, this building is actually equal distance both ways, but we've picked to run it this way, and we generally run it the longest dimension. And even though this ends shorter, we don't really want to turn it around and run on this way. We'll just keep going the same way. You can join your bearers. So obviously here we've had to lap them just by letting them run past each other over the pier. And if we had to join, say, this one here, we could butt joint them together, just butting the two ends together and making sure that's over an engaged pier. And then of course if you butt join them, it's not a bad idea to nail them together, and some people slap a gang nail on both sides just to stop them from spreading apart. So they're our bearers. So the next member is our joists. Now because this is a platform floor, we have double joists on all our external walls, and looks like I've forgotten one there, so let me throw that one in. So we've got to have double joists on all our external walls, and again, if we're going to join our joists, we can lap them past each other over a bearer, or if we need them to be in a straight line, we need to actually butt them together again over the bearer. And same again with the bearer, you can always whack a gang nail or nail them together to stop them spreading apart. Generally speaking, with our joists, they're spaced to suit our flooring, so generally nowadays 600 or 450 mil apart. If you're going to have a load bearing wall in the internal part of the house, then you need to make sure you have a joist underneath that wall. Okay, obviously the external walls are all going to be load bearing, so they've got two joists under them, but for an internal load bearing wall, it only needs the one joist. I'll show that again in a minute. And if it's a non-load bearing wall, you don't need any joist under it. I'll show that again as well in a minute. So there's our joists. You can then put down your flooring. Again, this comes in sheet sizes, 3.6 by 900 or 2.4 by 1.2, depending on what you're using. And because it's a platform floor, it goes down before the walls are put up. It runs all the way underneath where the wall's going to go, and that's why it's a platform floor. It all gives us a beautiful platform to build the rest of the house on. And then the walls go up, and as you can see here, come back in. As you can see here, our external wall has a double joist under it. A load bearing internal wall needs to have a single joist under it. and a internal non-load bearing wall can just sit in the middle of the flooring. It's not required to have anything under it. So there you go, there is a platform floor.